There's just a visualization. Okay, so now what happens to this solar energy? It just doesn't pass through. Most of the visible spectrum passes through, but a lot of the other energy actually doesn't make it. So I'm going to give you a list of a few things that can happen to the solar energy as it passes through our atmosphere. So one is, let's get some black in here, absorption. So that means that there are some gases that can absorb the solar radiation. If we look at this graph right here, what this is showing you is actually how the gas ozone absorbs a lot of the ultraviolet radiation from the sun. The ultraviolet radiation has different wavelengths, and these wavelengths are often referred to as UVC, UVB, and UVA, as you guys can see right here. And UVA tends to come through pretty well through our atmosphere and reach the surface of the earth. It's fairly harmless, so it's not of much concern. However, UVB, a lot of it gets absorbed in the atmosphere, and only some of it makes it down to the surface of the earth. And this is the UV rays that can give you a sunburn, and it can actually cause damage, DNA damage, and cause cancer. And it's not just humans, it's animals. In fact, I have a hairless dog, which sounds weird, but she's actually very cute. And they don't have any fur to protect themselves, so we have to put sunscreen on her. And we also have to put, putting a t-shirt on her. We have, clothing to help protect her from the sun. And plants can also get damaged by UV rays. This UVC right here actually gets completely absorbed. So what this graph is showing is on this axis, the amount of ozone. Again, it's a really small amount, but those gases that make up the small amount have an enormous impact in our atmosphere. So that's the amount based on the altitude. So the amount of ozone in our atmosphere changes with the altitude. And we're going to talk about the different layers like the troposphere and the stratosphere soon, and the mesosphere is up here. So it turns out in the stratopause, in the stratosphere, as you can see, the amount of ozone increases, and they refer to this area as the ozone layer. Just because there's more ozone in that layer of the atmosphere than all of the other parts of the atmosphere. It doesn't mean that it's only ozone or even that it has a lot of ozone. It just has a lot more ozone than the other areas. And ozone is, remember we were saying that oxygen is O2? Well, ozone is 3 oxygen atoms, and so it's O3. You should know that chemical symbol, ozone. Okay, O3. So there's a lot of O3 in the stratosphere, in the ozone layer, and it is really good at absorbing UV radiation, so it protects us. So have you ever heard of the hole in the ozone layer? The hole just refers to the fact that there's a lack of ozone, that there's far less ozone in that ozone layer than should be there. And since the ozone has decreased so much, it allows that UV radiation to come in and reach the surface of the earth, which is very damaging to us. So that's why it's really a big concern about the ozone hole, the hole in the ozone layer. More to come soon. Okay, I don't want to make this too long. All right, so we've got shortwave radiation coming from the sun. we have long wave radiation coming from the Earth. Some of the solar energy is absorbed, like ozone absorbs some of it. Another thing that can happen is some of it can be reflected back out to space. And we're going to talk about that in a moment. Some of it can be scattered. Okay, so it turns out that nitrogen and even oxygen are pretty good at scattering the blue wavelengths of the visible spectrum. So when we have a blue wavelength coming through, let's go ahead and get blue. Okay, so if we have a blue wavelength and it interacts one of these smaller molecules, that can scatter it in all directions. So some of it comes back towards Earth, but at these different angles. Some of it goes out here and here, okay, all over. That's scattering. And then the fourth one that I want you all to know is refraction. So it sounds like reflection, but it's refraction. And we're actually going to talk a little bit more about refraction throughout this semester because wavelengths, this is a property of energy moving as waves. When the waves of energy enter a certain medium, like molecules, they can be refracted, meaning that they can change direction. So let's say we have this wavelength and it enters and it refracts. Okay, so it just changes direction. That's refraction. So we can, we'll revisit that again too. So with some being absorbed, some being reflected, some being scattered out or refracted, then only part of the sun's energy reaches the surface of the Earth. All right. What else? Okay, before we leave, when we have scattered wavelengths and refracted wavelengths, then the sun's energy is not directly hitting from the sun to something on Earth. It's coming from different directions, from scattering and refraction. When it's coming from different directions like that, it's referred to as diffuse radiation. Diffuse radiation. So that's when the light, the sun's energy, does not hit directly on the Earth. And if it does, of course, we call it direct radiation. Now, if you block direct radiation with an object, you get a shadow. So if the sun is behind you and your body is blocking the sun, then it casts a shadow, right? Can you see inside a shadow? Your shadow, the shadow of a building, the shade of a tree. Can you see? I hope you can. Yes, the answer is yes, you can see. Guess why? Because of diffuse radiation. So because the molecules in our atmosphere are so good at scattering the blue wavelengths, that's why the sky is blue. No matter where we look, we can look around. It could be in the direction of the sun, off to the side, direction away from the sun, and it looks blue because that blue wavelength is being scattered by all of the molecules. Not all of the molecules, but the 99%, it's scattering that light so we can see blue and the rest gets through. But if we block that direct radiation, we cast a shadow. But we can see inside the shadow because there's light being scattered from other directions, not just light coming from the sun. It's so awesome. Take a look at your shadow. Watch it, how it changes as the sun's angle changes, how it changes as the clouds in the sky change. Whew. Phew. It's super cool. And then as far as reflection go, one of the best things to reflect the sun's energy, of course, are clouds. I'm going to make a cloud right here. Erase cloud. Okay. So that's going to reflect a lot of the sun's energy, and it's going to keep a lot of the direct radiation from hitting the earth. So if you have a really cloudy sky, then your shadow is going to be barely visible. Awesome. All right, so I'm going to end that here and see you in the next one.